Welcome to Mitsubishi Electric Nagoya Works Shinshiro Factory. Here we introduce you to the motors that are essential to our life. The Shinshiro factory was established in 1974 as a branch factory of Mitsubishi Electric's Nagoya Works. Since then, it has been an important base for manufacturing a wide variety of three-phase motors for industrial applications. Electric motors are used in many different aspects of our daily lives. Now, let's take a look into the world of motors, the machines that power every industry. If you were asked, what is something we absolutely can't live without, what would come to mind? Of course, we need water and air, but the foundation supporting our daily lives is the motor. Take, for example, tap water, something that is essential to our daily lives. Water from reservoirs and rivers is filtered at water treatment plants, then delivered through the network of water pipes to each individual household. A variety of different pumps, both large and small, play an active role at each stage, from the facilities of the water source to the treatment processes at water purification plants to pumping the water to the users. And driving all these pumps are motors. You'll find a wide variety of motors functioning everywhere in our lives. For example, motors drive elevators, escalators, automatic doors, and air conditioning in buildings. More examples include trains for commuting, conveyor belts and cranes in factories, and roller coasters at amusement parks. The power source in all of these cases is a motor. Looking around the home as well, from washing machines, refrigerators, and other home appliances to the computer and smartphone in front of you, motors are used in every area of our lives. Motors are truly hard at work in the background supporting our lives. Well then, here's a question. How many of these motors supporting our daily lives and infrastructure are produced in 1 year? The answer is over 6.5 billion motors a year. Based on trends for shipments to the global market for small and industrial motors, more than 17 million motors are manufactured every day. Moreover, the spread of EVs in recent years has increased demand for automotive motors, with the number of motors produced now approaching 10 billion units. The world is truly driven by motors. From electricity, gas, water, and other infrastructure to manufacturing sites, motors play a major role as an irreplaceable power source. Energy savings and higher efficiency in motors are now crucial issues in preserving our global environment. Converting electricity into mechanical energy, motors are intimately involved in our daily lives. If all the motors on Earth were to stop tomorrow, not only would we be unable to manufacture or transport goods, we would find it difficult just to live a normal life. With motors playing such an important role, the focus now is turning to their energy consumption. Motors currently in operation around the world consume a total of about 50% of the electricity used on the Earth. The largest consumers of electricity are industrial motors used in manufacturing and infrastructure. It is estimated that improving motors' efficiency by 5% would enable a savings of 2% of the total amount of power generated worldwide. In other words, as the efficiency of motors now operating around the world continues to improve, this will become a major contributing factor in mitigating future energy crises. To promote energy conservation on a global scale, we will need to see even further evolution in the motors of the next generation. Motors have evolved and been developed according to their usage and specifications. Now let's classify them according to the type of current they run on. DC-powered motors include DC motors and brushless DC motors. Brushless DC motors do not have brushes, but instead use semiconductor switches to produce rotation. AC motors running on alternating current are roughly classified into synchronous motors and induction motors. Synchronous motors combined with inverters and other components exhibit high performance. One type of synchronous motor with a number of special qualities, the reluctance motor, has been the focus of much attention in recent years. Induction motors are widely used due to their convenience, as they can run directly off commercial power supplies. Now, let's look at the principles of how motors operate. Motors use electromagnets consisting of a coil of wire wound around an iron core. This structure becomes a magnet when an electric current is passed through the wire. The north and south poles of an electromagnet can be switched by reversing the direction of the electric current. A motor utilizes the electromagnetic forces of attraction and repulsion to create motion. Let us set up an arrangement consisting of an electromagnet with a rotating shaft in the center and the north and south poles of permanent magnets to the left and right. When a current is passed through the coil in this setup, the south and north poles attract each other and the electromagnet in the center rotates clockwise. Using the characteristic of magnets whereby opposite poles attract each other and the same poles repel each other, then switching the flow of electricity with the proper timing will cause the rotor at the center to continue rotating. Since their invention in the 1800s, motors that operate on this principle have seen tremendous strides with reduced size and weight, higher efficiency, and less noise and vibration. In addition, thanks to the development of inverters and servo amplifiers that control mechanical speed and allow accurate, smooth, stable operation, motors have come to be used in a wide range of fields, including industrial machinery, robotics, and electric vehicles. Now let's take a look at the structure of the main type of motor produced by the Nagoya Works Shinshiro factory, the three-phase induction motor. Do you know what the three-phase in three-phase induction motor means? Electric power is mainly supplied in one of two ways: single-phase AC power for home appliances and other relatively small electrical equipment, and three-phase AC power, which is used in supplying electricity for industrial equipment and other applications requiring large amounts of power. Many factories and infrastructure facilities use three-phase power, which utilizes three phases to allow continuous transmission of maximum voltage with minimal lag, providing a stable supply of power. That's right. The three-phase induction motor is called that because it uses a three-phase AC power supply. Let's take a look at how the three-phase induction motor works. Here we see the internal structure of a three-phase induction motor. The stator has three sets of coils that are excited with a phase difference of 120 degrees. Connected to the shaft is the rotor. Many of the motors manufactured at the Shinshiro factory utilize a so-called squirrel cage rotor. Consisting of two rings connected by numerous slats, it is called a squirrel cage rotor because it rotates like a hamster's exercise wheel. The squirrel cage rotor is equipped with a large number of laminated steel plates that serve to concentrate the magnetic field. When the stator coil is connected to the three-phase alternating power source and the current's applied, a rotating magnetic field is generated. When this magnetic field crosses the rotor, it interacts with the rotor, which then begins to turn. Here, the rotor's rotation is delayed relative to the magnetic field of the stator, and this sustains the rotation. That is the principle of a three-phase induction motor. Although the three-phase induction motor incorporates technologies handed down since the invention of the motor, various technological innovations along the way have led to tremendous advances. One example is our high-efficiency, energy-saving Mitsubishi Electric Superline Premium Series SFPR. Mitsubishi Electric's also making progress in commercializing products that take advantage of these characteristics of the latest synchronous reluctance motors mentioned earlier in the section on motor types. 2020 saw the world's first test run of the synchronous reluctance motor system, a unique propulsion system for railway cars, with the system installed in 13,000 series cars on the Tokyo Metro Hibiya line. Leveraging the motor's characteristics of high torque and high efficiency in the medium and high-speed ranges, testing confirmed the system's running performance and superior energy savings in a real-world environment. The Sustainable Motor Series RFSR Mel Susmo was developed at the Shinshiro factory as a new reluctance motor product. Elimination of permanent magnets saves resources, enhances ease of maintenance, and reduces power consumption in manufacturing. And with its IE5 rating, the highest efficiency class, this motor will make a tremendous contribution to the creation of a sustainable society. Well, what do you think about the world of motors, so prevalent and yet so little known? The technologies behind these motors supporting our daily lives will also be crucial technologies for the future. There is a future in which next-generation motors featuring the very latest in technologies for greater efficiency, energy savings, greater compactness, and lower noise and vibration will lead to a new world. That future's already here. Aiming to provide next-generation motors offering higher efficiency and energy savings, Mitsubishi Electric Nagoya Works Shinshiro factory has brought together the latest in mechatronics and systems technologies. We constantly challenge ourselves to create a new future of high quality and high functionality that motors represent. The Shinshiro factory's work in telling the world of our traditional and cutting-edge technologies are introduced in the factory tour video. We invite you to view it.